All right, everybody. In this video, we are going to look at a few specific operations that we can do with our pointers in C. So, after watching this video, you should feel comfortable using pointers appropriately in order to work with dynamic memory in C. So, remember from the previous video that talked about what pointers are, why we use them. Remember that pointers are references to the address of a variable rather than the specific value of that variable. So in a lot of the languages that you've been working with, you've been just referencing the value, but with pointers we can also reference the address. And this is particularly useful when you're working with a piece of data that's dynamically sized. So a string, an array, a struct, something like that. A few specific things that we can do with our pointers that are helpful include some concepts like pointer arithmetic, allocating memory. So we're going to walk through some of these different operations and then how you can actually use them. So pointer arithmetic, all right? So remember that when you're given a pointer to, let's say, a string, that pointer references the first character in your string, not the entire string itself. So if you wanted to access the second character, the third character, the fourth, fifth, sixth, seventh, eighth character, you would need to modify or increment the pointer that you started off with to access those subsequent characters. And same thing if you're working with an array. Remember, the pointer to your array is actually just pointing to the first element in your array. So if you want to do something with the second element, the third element, the last element, you're going to need to increment that pointer. And this is something that we can do. All right. What else can we do? So let's look at an example of what this would actually look like. So in this example here, first thing I've done is I've created a pointer to the string hello world. So the variable str is going to reference the address, not the value. Okay? And so if I want to print out the first character in that string, I can dereference that pointer. So I've included the star, the asterisk there to dereference my pointer. That will go ahead and grab the first character. But if I wanted to print the next character in my string, I'm going to need to increment the value of that pointer. And so how we can do this, we can simply increment it, and we know the next character is going to be the next block of memory. So I can increment this by 1 to access the next character in my string and print that out. Now, one thing to make sure that you pay attention to, so when we are dereferencing a pointer, when we're using the star, that operator, the dereference operator, it actually will, when you're thinking about order of operations, it takes precedence over arithmetic operations like addition, subtraction, multiplication, division, etc., etc. So because I want to increment the pointer, right, go to the next address space before I dereference it, before I grab the character at that address space, I do have to put my pointer arithmetic in parentheses to make sure that that arithmetic operation happens first. So just something to be careful, because otherwise I'll dereference the pointer and then try to add 1 to it, which doesn't make a whole lot of sense. Okay, so just something to pay attention to. The other operation that you will probably find yourself doing often when working with pointers is you will be performing manual memory allocation, right? So you will have to be creating a block of memory that is the specific size that you want it to be. And we do this with a function called malloc, right? Malloc takes in one parameter, and that parameter is the amount of bytes, okay, so how much memory in bytes that the user wants to allocate for some purpose, right? What malloc then does, it takes that size constraint that you've passed in, and it looks for a contiguous spot in memory, right? One block of memory that fits that size requirement, and it will return a pointer to where that block of memory starts. So it will point to the first address space in that block of memory. So let's take a look at how this would work. So I know we've said a few times that you don't have to use pointers when working with data types of a fixed size, but potentially it could be useful. So here's one example where we're working with integers. So this is a data type that has a fixed size, but I want to create a space in memory that's going to hold 100 integers. Okay, and I can do this using malloc. So remember, malloc takes one parameter. I need to say how many bytes that I need my program to allocate for all of these integers, right? So first thing that I'm going to do is, okay, think about what am I storing in this block of memory. I'm storing integers, and there's a handy size of function that we can use that will return how many bytes are needed for that particular data type. So you can use size of int, size of double, size of character, etc., etc. Okay, so we're going to take the size of a single integer, and if we look at, okay, what is it I'm exactly trying to do? I want a space that is big enough to hold 100 integers. So I need to take the size of one integer, multiply it by 100, and that will give me the total number of bytes that I would like allocated in this one piece as one block of memory. And then I'm saving that. Remember, malloc returns a pointer. So I'm saving the result of this function in the pointer called 100 ints. We know that it's a pointer because when I declare this variable, I've got my star there to indicate that I am declaring a pointer that's going to reference an address. Okay? And then if I wanted to, so right now I've created a space in my program's memory, but it's empty. So it's big enough to hold 100 integers, but I haven't actually put any integers in it. So then if you wanted to use this pointer to then fill that block of memory with 100 integers, you could set up a loop. Again, we know exactly how many integers we're going to put here. We're going to have 100, so I could loop from 0 to 100, and then create a random integer every time, and you'll see we're using our pointer arithmetic there to update what address we are referencing. Okay, so I'm saying, okay, take the initial pointer, the pointer to the first block of memory, increment it by I. Okay, so if I'm, depending on which integer I'm inserting, okay, I need to shift over a few slots, right? We're not always going to be inserting at the first block of memory. And then I'm dereferencing my pointer because I actually want to change the value. I want to put a specific random integer into that location of memory. And remember, anytime that you're dealing with values, whether you're accessing a value, changing a value, you want to make sure that you dereference your pointer. Okay? The other thing that you will probably do that can be very useful when you're working with pointers is use pointers as parameters to a function. So typically in the past, probably what you have become pretty used to doing is something called passing your parameters by value. So when you pass a parameter to a function by value, essentially you're creating a copy of whatever value you want to use. You're passing that over to your function. Your function's doing something with that copy, but then when the function terminates, any changes that you made to that parameter are gone because it was a copy. You weren't directly modifying whatever variable was passed as a parameter. If you want to take that parameter and return some changes to it, you're going to actually have to return some new value if you want those changes to stick after the function has terminated. And this is good in a lot of scenarios, but there can be, maybe let's say the value that you're passing is really big. Well, maybe you start to see if you're making a lot of calls to this function where you're passing in these really big parameters, your program might start to see some performance issues. So we can actually pass pointers as parameters to our function, and we refer to this as pass by reference. So we're not passing a value to our function, we're actually giving it an address, and we can use that address to go get a value that we need to use. So when we're passing parameters by reference, the parameter is a pointer. Okay, this can be cheaper, more efficient if we're working with really large arrays or strings or objects. Okay, and if we use our pointer and we manipulate the value of whatever item is at the address referenced by that pointer, any changes we make will actually be maintained even when the function ends, because we didn't pass in a copy of some value, we passed in the address of, okay, this is the value I need to use, this is where that value is saved, and so if we change it, we're changing the original copy. So you have to be careful. This isn't always necessarily what you want to do, but many times it could be. So this can be a useful thing to do. All right, so let's look at an example. So let's say that I have a really, really long string. I don't want to pass the string as a parameter, but I want to print out that string. I could pass in a pointer to that string. And it's probably also helpful to have the length of that string. Then I'm going to have to go character by character as I'm printing out this string, because remember, the pointer to my string is really just pointing to the first character. So if I want to print out the whole entire string, I'm going to have to do some pointer arithmetic to iterate through all the characters in my string. So I've got a for loop set up that will do that. And then inside my for loop, I can just print out the character that I get at every single address within the block that has been allocated for this string. And because I'm using the specific value, I want the value of each character, I'm dereferencing my pointer and making sure that my pointer arithmetic is in parentheses before I dereference it, so that order of operations does not get messed up. Okay, so to sum all of this up, there are a few different operations that we can do with our pointers that are super useful. We can use pointer arithmetic to iterate through all the values within a block of memory. We can use malloc to allocate a block of memory of a certain size. And we can also pass pointers to functions, which allows us to manipulate really large pieces of data, can lead to more efficient processing in certain scenarios, and allows changes to our parameters to be maintained after a function terminates.